Welcome to our channel. Today, we're diving into a fundamental concept in statistics that plays a crucial role in data analysis: standard deviation. Have you ever wondered how we measure the variability of data? Whether you're an investor assessing the risk of stocks, a teacher evaluating student performance, or a manufacturer ensuring product quality, understanding standard deviation can provide valuable insights.
In simple terms, standard deviation tells us how spread out the numbers in a data set are. A low standard deviation means the data points are close to the mean, while a high standard deviation indicates a wider spread. In this video, we'll break down the steps to calculate standard deviation, explore its significance, and look at real-world applications that highlight its importance. By the end, you'll have a solid understanding of how standard deviation can help you make informed decisions based on data.
So let's get started and unlock the power of standard deviation together. Calculating the standard deviation involves several steps. Here's a simple example to illustrate the process. Example dataset. Let's say we have the following dataset: 4, 8, 6, 5, 3.
Steps to calculate standard deviation. Calculate the mean. The mean, often referred to as the average, is the sum of all values in a data set divided by the number of values representing a central point. A low standard deviation means the data points are close to the mean of the data. Mean equals sum of all data points over number of data points. So we have for plus 8 plus 6 plus 5 plus 3 divided by 5 equals to 26 over 5, which is 5.2.
Calculate the variance. Variance is a statistical measure that quantifies the degree to which data points in a set differ from the mean, indicating the spread or dispersion of the data. Subtract the mean from each data point and square the result. 4 minus 5.2 squared equals negative 1.2 squared equals 1.44. 8 minus 5.2 squared equals 2.8 squared equals 7.84. 6 minus 5.2 squared equals 0.8 squared equals 0.64. 5 minus 5.2 squared equals negative 0.2 squared equals 0.04. 3 minus 5.2 squared equals negative 2.2 squared equals 4.84.
Now, calculate the average of these squared differences. 1.44 plus 7.84 plus 0.64 plus 0.04 plus 4.84 divide by 5 equals 14.8 over 5 equals 2.96. Calculate the standard deviation. The standard deviation is the square root of the variance. Standard deviation equal to the square root of 2.96, which is approximately equal to 1.72.
Summary. For the dataset 4, 8, 6, 5, 3. Mean equals 5.2. Variance equals 2.96. Standard deviation approximately 1.72. This process can be applied to any dataset to find the standard deviation, which measures the amount of variation or dispersion in a set of values. Standard deviation is a widely used statistical measure that helps to understand the variability or dispersion of a dataset. Here are two examples of its applications. 1. Finance and investment.
In finance, standard deviation is used to measure the risk or volatility of an investment. For example, if an investor is considering two different stocks, they can calculate the standard deviation of the returns for each stock over a specific period. A stock with a high standard deviation indicates that its returns are more spread out and thus more volatile, suggesting higher risk. Conversely, a stock with a low standard deviation indicates more stable returns, suggesting lower risk. Investors often use this information to make informed decisions about which stocks to include in their portfolios based on their risk tolerance.
2. Quality control in manufacturing. In manufacturing, standard deviation is used to monitor and control the quality of products. For instance, a company producing light bulbs may measure the lifespan of a sample of bulbs. By calculating the standard deviation of the lifespans, the company can determine how consistent the product quality is. A low standard deviation indicates that the lifespans of the bulbs are close to the average, suggesting high quality and consistency. A high standard deviation may indicate problems in the manufacturing process, prompting further investigation and adjustments to improve quality control. These applications demonstrate how standard deviation can provide valuable insights in various fields, helping to assess risk and ensure quality.